Hello and welcome to Spatial. Today I'm going to show my workflow on how I do land use, land cover. Alright, so I'm going to take you step by step on how I do land use, land cover. At the end of this, you'll be able to see how I do my own. Alright, so I'm not saying it's different, but this is how I do mine. So let's right into the video. So first and foremost, I have to download the Landsat imagery. And I'm using Explorer. So Explorer is a website belonging to United States Geological Survey. And first you need to log into or sign up for an account with the USGS. So I am already signed in. So if I come up here, you see that there's Geospatial. And then the next thing is that you're going to search. Once you're signed in, you have three options here. We have the future, which is GNIS, and then you have the address and the path and rule. And then I'm going to use the address, which means I'm just going to input a location. And in this case, I want to use Kaduna Metropolis. So I'm going to just type Kaduna, and I'm going to search on this show. So you see Kaduna with a postal code on it. So, and then with the longitude and latitude. So once I click on here once, it's going to bring me here to this place. And then next is the data set. So I need a 2025 since we're in 2025. So I'm going to take it to 2025 only. So I'm going to go to data set, and then I'm going to select Landsat 8 to 9. And then I'm going to click on result. So on this result, I'm going to use a Landsat 9, which we are seeing here. But you will want to know what are the cloud cover that are on the image. All right, so the level of cloud cover, it should not be, they used to say it should be less than 10, but I'm telling you, you should have a 0 cloud cover, because the image itself is having atmospheric errors. So you should try and look for the ones with 0 cloud cover. This we have 0.02. We can use this, but I know we have others that are actually 0. So we'll keep looking. We have 0.05 here. I'm still going to go down to check more. So we're going from, so we have 0.00 here. So depending on the month you're looking for, but I don't have anyone in mind right now, and depending on the level of data required. So I only have one image, which I'm trying to show you a flow of how I do my one Landsat scene. That's if my study is falling within one Landsat scene. So now that I've checked this, I'm going to click on this download here, and I'm going to click on product. It's the 1.1 gigabyte. So I'm going to click on download. So now it's coming up to download. So I'm just going to allow it to download. So let's wait for it to download, and then we continue. So now our Landsat is downloaded, so we'll locate the folder to which the Landsat is, and then we are going to extract it. So this is our Landsat, and we're going to right click, and then you need a 7-zip to be able to extract. Either you have a WinRAR or you have a 7-zip. So I have a 7-zip, and I'm just going to come down here. I'm going to click on extract. So now we have it extracted. So now basically we're going to go into pre-processing of this very image. All right, so we're going to open up our ERDAS Imagine, and we're going to come to, I have ERDAS Imagine 2022. So once you come in, it's going to be somewhere around here like this. So you're going to click on raster, and then on raster you go to spectra. So and you go to layer stack. What we want to do here is that we want to want to do composite, that's we're going to have combine the bands to have the color that it represents, whether it's a build-up, it's a water body, and the rest. So it's a combination of 3-band RGB. That's red, green, blue. All right. So, and then we're just going to go into the folder, and then this is the Landsat. We have Landsat 8 for this, and then we're going to click on this band 1, and then we'll click, and then we'll add it. Click on band 2, we add. We click on band 3, we add. Click on band 4, we add. Click on band 5, we add. And finally we add band 7. Then we're going to come to an output here, and then we will select a location. So like I used to do, or as is my culture, I always create a folder. So I'm going to create a folder, and I'm going to name it layer stack. So that gives me a kind of sense of organization. So I organize my data based on what I'm doing, so that in case the brain is not allowing you to think, you can be able to know that, oh, this is what I'm doing. All right. So I'm just going to, since it's a one location scene, I'm just going to, that we're using one Landsat scene, I'm just going to name it Kaduna. So so that I don't have to confuse myself. And then once that is done like this, I'll click on OK. So once this is done, I'm going to click on dismiss, and I'm going to click on OK. All right. So the next thing I normally do is I pan-sharp the image. All right. So pan-sharpening is that you increase the resolution of the image, because this has a kind of a chromatic band inside of this bands you see that comes with the Landsat. So the panchromatic band comes in a 15 meters, so you use it to rub across the ones you've done, and then it's going to rub. So we have quite a list of the method you're going to use for them. We have resolution merge, and we have modify AHI resolution merge. So I use this preferably for me. It worked for me. So, but these two are the ones I can recommend: resolution merge and then the modify IHS resolution match. So I'm going to go with it. So next is that this high resolution input file is the panchromatic band. So this will take us to the folder that contains those the Landsat images. All right, so we're going to be using band 8 because that is the panchromatic band. So once it comes in, the sensor will be Landsat 8 panchromatic band. All right, so here will be multispectral input, that is those ones I combine together. So I'm just going to go into AHP, and then I'm going to go to layer stack, and I'm going to click on Kaduna, and then I'll bring it in. So once this is in, the sensor of this will be Landsat 8. Okay, so the sensor will be Landsat 8, but I can see that what we have is not a thermal band. So let me just put it at custom. All right, I'm going to leave it at custom because it's supposed to be Landsat 8 sensor, but okay, let's leave it since it's showing 8 anyway. The sensor is Landsat 8 ARA. So, and then the next thing we'll do is that now we have resampling techniques, whether we're going to use nearest neighbor or we're going to use cubic convolution, we're going to use bilinear interpolation. So it depends on which one. So you can read up on these three and then look at which one will be more convenient or will be more appropriate for what you want to do. So I'm just going to go with the default. It's going to be the bilinear interpolation. So next I'm going to layer selection. Now on this layer selection, I want you to select your RGB. Alright, so which bands do you want to use for your work? So let's leave it at custom, and then I don't know what's wrong. Let's don't know what is wrong. Let's leave it at default, but it's not. Okay, so just the sensor is band 8. Where is band 8? Band 8 panchromatic, and then this is yes, Landsat 8 MSI. All right. Okay, good. I think there was a mix-up somehow, but we're back now. Then the number of bands we imputed were 7. Okay, so we go back to our selection now. So we have already made ones that you can easily use. First color, agriculture 652. So let's change it to this one so that we can have multiple RGB. So let's take this in. Then we have healthy vegetation 562. We bring it in. Then we have, let's see, we have two color 431. Then let's look at if we can get anything on atmospheric penetration. First natural color, let's bring this 1 2 3 4. Okay, let's see if we can get 543. All right, so you can add as many of these as possible. All right, so we have 5 attriation. So the more you add, just know that you're going to require a whole lot of time, and then the system being used will have to be also strong. So we have 5. Let me add 1 so that it can be 6. Okay, let's see TM. Let's see if we should use, let's use this. So we have 6 altogether. So now we'll move to output, where we just bring in we write what we want to have as. So under AHP, that's what we're saving it. So we'll create another one. We'll create another of this, and then we're going to have a name of a folder. So we call the folder sharp. Alright, so we now put in our Kaduna as well. Kaduna, and we say pan sharp. So we're going to click on OK, and then processing option, you can ignore 0 in raster match, you can all of that, but anyone that you feel like doing for you, you can do that. But I normally don't check this. And then the image is on signed 16-bit, so both of the high resolution and the multispectra. So you click on OK and watch it process. So finally it's done. So we'll close this, and then we bring it in the pan sharp. So you right click and then you click on fit to this. So now the next thing we're going to do is we're going to just go to multispectra, and then we change some of the bands to see what we'll come up with. Alright, so let's do 541. Okay, so this is what we have, and next is we're going to bring in the study area to clip out what we want. But most of the times, I classify the whole Landsat scene, then I clip it out. So let's try that one. Let's go with that. So to do classification, I use two software, the ERDAS Imagine, which I divide into. For those of you who have seen my classification and any of the thing I do using this, so I have these two software, Google Earth and the ERDAS Imagine itself. So I'll go to Google Earth. Now for this 2015, select a specific kind of Google Earth to accept. But 2022, anyone you brings in, it takes it. So in 2015, you must have version 6.13, sorry, version 7.1.3 for it to work. But this one goes with anyone. That's why I like the 2022. Alright, so you click on connect to Google Earth, and then you click on match Google Earth to views. Then you can sync it. Alright, so this is going to be synced across this whole place. So I'm going to just do a 4 classes kind of classification here. So let's start with water body. So you're going to go to raster, and you're going to go to classification, and then you go to supervise. Because the reason why it's compressed is because I include this, so it has to bring the two of them together and all that. So you go to signature editor, but if it's on full while, you just see supervised, and then you take your signature editor. All right, so okay, so we have our signature editor here, and then the next tool you need is a drawing tool that contains what we'll be using. So this is a polygon tool, so this will go a long way when you're trying to do so. For me, I just pick it along the river bank. I don't go too out, I just go within, and then I'm going to drop that, and I'm going to click on this. Alright, this video I'm not going to do accuracy assessment. Alright, I'm just going to move right into just doing classification in basics. So if I'm to do accuracy assessment, I'll open my Excel and be picking coordinate of these river areas. Alright, but I'm not going to do accuracy assessment. So once you are done selecting this, you will just join them together, and then you click on this. It will match the signature together. So you right click and delete this, then you turn this to the appropriate class that it belongs to. So it is water body. So we change it to the color blue. All right, so now you save this so that you don't have to, maybe in case of anything, you don't have to miss maybe outage or anything. So let's just save it. I'm just going to see Kaduna. Okay, so it's saved. You can see that the signature is saved. So we'll run this through for the remaining class, and we'll return. So we are done with the forecast, and you can see the forecast here. So I believe while we're going, you were seeing the way this Google Earth has been so instrumental in helping in identifying, even though the image is now 15 meters. Yeah, so if you check, this place is bare land, and then this has helped us to check that too. And then with the help of the image being sharper than it should be, I didn't compare the previous image and this. So let me bring the previous image so that we can make that comparison quickly before we continue. Now, now look at this place, how it is here, and then look at it here. Did you see? It has sharpened in such a way that it has distinguished some of the bands out that you can now see clearly and better compared to the previous one. So this was 30 meter. So let's go to attribute table. Is it attribute table? Yeah, let's go and see. I don't think it's attribute table. What is the metadata? Sorry. So we'll look at this from the metadata so that you see what I'm saying. Alright, so look at the metadata. Okay, so when you look at the metadata, you will see that pixel data. Okay, sorry. Let's come to general. You see that the pixel size is 30, right? 30 meter. Now let's look at this one now. It's 15. So this second one that we pan sharp is sharper than the previous one. So it helps us in distinguishing some of the whole thing. Now I use this even though it's kind of stressful, but I use it because it helps you to distinguish some of this image. You see, especially this water body, you can see how distinguished it is from other features. You can see how clear it's showing. So this is the way I do my workflow. So now what is left now is for us to go ahead and make classification of this. Alright, so from here I can easily see classify here. I not necessarily need to come here. You can come to raster and then go to classification, supervise, and then supervise classification. Well, here you can just click on classify and then go to supervise classification, and you go to output and you select where you want it to be. So I'm going to say, and just keep it here, and I'm going to classify image, or I can say classify let's put classify. Alright, so classify, and then I'm going to OK it, and normally I don't touch anything here, but you see where parametric rules, it must be maximal likelihood. Alright, so let's click on OK and allow it classify. So while it is classifying, we need to do something on ArcGIS, which is something we're supposed to have done before, but it's not too bad for us to do it now. Alright, okay, so what we wanted to do is to define the study area. I know when you're using administrative boundaries, you have to get the shapefile. Alright, so I'm going to click on add and then go right into where I keep all my shapefiles. Alright, so we have it's Kaduna North and South that we're using. So this is Kaduna North and South. So what I want to do is, most of the times when you this shape files that comes most of the times comes in GCS, and then the Landsat imagery comes in WGS projection. So we have projection 32, 33, and 34, right? So you see GCS 1984. So for you to be able to clip or subset on ERDAS Imagine, the shapefile you're bringing in must have the same coordinate system as that of the Landsat imagery. So what I normally, sometimes if you, after removing this and you project, you may not really get the whole thing. So what I normally do is that I quickly create a shapefile. So I create a shapefile, and so I'm just going to right click on this, go to new, and then go to shapefile, and then I'm just going to say CAD, because it's Kaduna Metro, and then there's going to be a polygon. Then the coordinate system now, Kaduna Metropolis or Kaduna State entirely is in MENA Zone 32, but we're going to use WGS 1984 UTM Zone 32. Then you click on OK. So now as created, the next thing I'm going to just go to editor and start editor, then click on CAD, click on OK, and I'm going to come to this and click on the card. Then I'm going to come up to trace. Then I'm going to click here and then trace it round. So once I do that, I say finish trace. So it has finished. I'm going to stop editing and then say yes. Now, this is what I have of Kaduna Metro. So what next we need to do is to go back to our ERDAS. Okay, we see that what we're doing here has finished, so we just dismiss and close. So we can remove this. I can save it for future use, but I'm not having anything to do with it again, so I'm just going to dismiss that. All right. So I'm not going to save it, so I'm just going to cancel it. My system space is down, that's why it's showing me my system space free. So you need to have enough space if you're doing this, especially when you're going to pan-sharpening, pan-chromatic sharpening. So that's why you see it's finished over 50 gig down to 7.7. So that's why my system is running slow. But we're about to finish, so let me just continue. So, alright, so now we will remove this and bring in our classify. So right click and zoom this to layer. So this is our classification. So we have Google Earth to make some verification, right? So but from indication we see that our water body is properly done. Now what we don't know is if our build-up is done well. I'm not sure the build-up is done well because it's like water body is taking, vegetation takes over most of the built-up area. I don't know that which, but we'll verify that soon. Alright, so now what we want to do is let's not do our verification first. We'll verify that once we bring in all of that. So now what we want to do is we want to bring in the shapefile and clip our study area. So you right click on this, then you go to open vector. Just right click anywhere within the workspace, and then you go to open vector. So we kept that on, I cannot remember where I kept that, but let me check that from ArcGIS. where I did kept it. Sorry, you'll bear with me, my system space is very limited, so it's dragging feet and all that. So I just want to check where we kept that, because like I created and forgot. Okay, so we have it at MSc Research, okay. So we're going to go back and get the MSc Research folder here. So here is the research folder, and we have CAD, what we created. So click on OK. So this is where it is. So let's remove and see. It did well. Yeah, so now if we remove this to verify, you see that there are quite a number of built up and all that here. So, but what we want to do is we just want to clip it. So you click on this, it turns yellow. Once you click on this, it turns yellow. So once it turns yellow, you come to manage data. Sorry, you come back home, and then you see this paste from selected object at home. Paste from selected object, you click on it. So this turns to an AOI because they are of the same area. So now if we are verifying, you will see that this actually represents what we are doing. Kaduna South is, North and South is actually developed, right? So what we need to do next is we click on this for this to be highlighted in an angular form like this. So the next thing we need to do is to go back to raster, and then you go to geometry, and then you come to subset and chip. So you click on it, create a subset image. So a dialog box will be open like this, so you just put in your output. So we put in our output as CAD Metro. So I'm just going to leave that without the R because my keyboard is not having R. So the next thing we want to do here is we come down to AOI. Click on AOI. Then because this AOI is currently on this spot, we just need to select viewer. If we have saved it previously, we'll go to AOI file and import it. So you just click on OK, and finally you click on OK. So we have that done. Okay, almost done. So it's done. Okay, it's not still done. Still doing. So once it's done, you see this dismiss. But let's just click on. It's not done yet. So it's still still working. So it's done, so you just click on display and then you click on close. So let's remove this. So just uncheck it so that and we bring in this Kaduna Metro. So we have our this extracted. Now one advantage with extracting this is that it comes with every other thing out of it. So you see our water body, vegetations, built up, and bare lands are all in it. So the next thing is that we're going to come onto table, and then we're going to open show attributes, and then we'll click on area. So this will add an area in hectares or in acres or in square miles. But we are Nigerians and we use metric system, so we're going to add hectares. So you click on OK. Now you see that this will add the areas for you. So we have vegetation, we have this, but I don't even understand this. Let's add it again. So all right. So it has added the areas to 8. So what we'll do now is that we'll take this to ArcGIS, and then we're going to finalize the map. So basically this is how I do my workflow in terms of land use, land cover for a single Landsat scene. So sometimes I subset this into just the image, and then from here I do the classification, but this is better because you can easily do a larger area and then clip just to your study area. So if this have helped you in any way, sorry my voice, if this has helped you in any way, so if this has helped you in any way, do consider subscribing, like, share, and recommend this channel to your friends and loved ones. So thank you for watching this. I will see you in the next video where I'm going to do that for a more than one Landsat scene. Thank you for watching. See you in the next one.